Did you know that mining creates more waste than any other human activity? During this presentation, a staggering 570,000 tons of mine waste will be generated. That's enough to fill several Olympic-sized swimming pools. So you may ask, is there nothing useful that we could do with all this waste? Well, my research is focused on using electricity to recover as many metals as possible from this waste. So why is this important? During the next several decades, we will all be part of one of the biggest transformations in human history, the race towards a carbon-neutral economy. To make this work, we will need an incredible amount of metals because products like wind turbines and electric cars cannot be built without them. Now, where to find these metals is another question, because most newly discovered ore bodies have a lower and lower metal content and would create even more waste on the environment. That's where it gets really interesting to look at all the metals that are locked up in our mine waste, specifically a category of mine waste called tailings. Tailings are finely crushed, making it easy to liberate metals. Importantly, legacy tailings dams which are 20, 30 or more years old contain higher amounts of critical metals and rare earth elements as they were not considered important during those times. At the moment, recovering metals from tailings is often uneconomical, one of the key reasons being all the existing methods rely on taking the tailings out of the dam, transferring it into a processing plant, processing it and transferring it back to the waste tailings dam. My research could make all these steps unnecessary and allow us to directly extract metals from inside the tailings dam. So how does this method work? I combine two existing technologies. One is electrokinetics and the other is in situ recovery. We install electrodes which produce an electric field across the tailings dam. Then we add a specially designed solution which helps the release of metals. Metal ions being positively charged are attracted towards the negatively charged electrode, from where we recover them in concentrated form. In fact, we have successfully extracted 80% of copper from a tailings sample in our laboratory scale experiments. We are now taking the next steps to demonstrate that the method would work when it is scaled up. So why is this good news for Western Australia? Extracting metals would help us economically and to achieve our net zero emission goals. On top of that, it could reduce the waste material toxicity and lower the impact for the environment. With over 30,000 tailings dams all over the world, imagine the impact we could make as we unlock a new source of metals and embrace the circular economy. Let's rethink the way we look at mine waste management and innovate to turn waste into wealth.